Okay guys, we're going to finish up 10-2. Feeling good, feeling good. We're getting closer and closer. Okay, finishing up 10-2, we're going to talk about significance tests for the difference of two means. Okay, we got a great example here to go by because the stronger picker-upper. Okay, commercials for Bounty paper towels. Manufacturer claims that they are the quicker picker-upper. You guys probably don't know that, but your parents would because the commercials have been on for years. Okay, but they also the stronger picker-upper. Two AP Stats students decided to find out. They selected a random sample of 30 Bounty paper towels and a random sample of 30 generic paper towels and measured their strength when wet. To do this, they uniformly soaked each paper towel with 4 ounces of water, held two opposite edges of the paper towel, and counted how many quarters each paper towel could hold until ripping. Alternating brands, here are their results. Display these distributions using parallel box plots and briefly compare these distributions. Based on only the box plots, discuss whether or not you think the mean for Bounty is significantly higher than the mean for generic. And then we do a significance test and then interpret a p-value. Good stuff here, really good stuff, okay? When you look at this question, okay, this could be a free response question on the actual test, okay, where in the first part of it, they have you describe distributions, okay, describe or compare distributions, okay, you're describing, it says compare, not describe, compare, okay, that's that poster up there. Okay, we're going to talk about that, very important. I would not be surprised at all if they ask you something like that in the actual exam. Okay, the significance test. We know we're going to have significance tests in this exam, we just don't know what type. Interpreting a p-value, also something else that we're going to see. So, I want you to take a minute, okay, to enter all of these into your calculator. You know what? I did it already, so I guess you don't need to do that. So, as long as you can see my box plots here, okay, so I entered all of my data, okay, as you can see here, or hopefully you can see, all of the data is entered in there. So I'm going to go to second step plot, and I'm going to turn these plots on, okay, and then I'm going to go down to parallel box plots, or a box plot here, okay, and I'm going to turn on the one with outliers. And that's L1, so that one's good. And then I go up top and I go to plot 2, and I'm going to turn that one on. And then I go down here and I want that also to be box plot with outliers. And then I go down here in my X list and I make that L2. And then I'm going to hit graph. Looks like I've got something in my Y equals. I do, so I clear that out. And then I hit graph again. And then I'm going to hit zoom 9 to zoom in. And there are my two box plots, okay? So, we want to compare these two box plots. So to compare the box plots, we have to talk about, you probably can't see this, shape, outlier, center, spread, socks. Okay, compare your socks. And we are going to use comparison words. We are going to use comparison words, okay? Now, when I look at these two box plots, you could look at this one. We're going to start with the shape. And the top one is Bounty, and the bottom one is the generic paper towels, okay? So, if we're talking about the shape for Bounty, okay? I don't know. Maybe there could be a slight left skew to the Bounty paper towels. Whereas in the generic paper towels, it looks like the distribution is roughly symmetric, but there are two outliers, okay? So we're talking about the shape, we're comparing the shape, okay? The Bounty ones, the shape for the Bounty paper towels looks like there's maybe a little slight left skew, whereas for the generic ones, it looks to be roughly symmetric with a couple of outliers. Okay, so I did my shape. We already talked about the outliers. We talked about that within our shape. Center. The mean for Bounty is much greater than the mean for generic paper towels. Okay? The spread, you could look at the spread. Let's do that. Okay? Let's look at the spread for these two. Okay? Let's hit trace. So this is going from 103 to 128, and the bottom one, so what's that, 103 to 128, so the spread there is 25. Here it goes from 77 to 103, so you could say the spread of each distribution, or the spread of the Bounty distribution and the generic distribution are roughly the same. Okay, they're about 25. All right, so we did that. We did the shape outlier center spread, and we used comparison words. You have to use comparison words or they're not going to give you credit. Okay, so let's get that calculator out of the way. And now let's do a significance test. We want to do a significance test to determine if there's convincing evidence that Bounty paper towel can hold more weight. Okay, so ready? Here we go. We want to test H subscript 0. The null hypothesis, there is no change. Okay, the mean for Bounty minus the mean for generic is equal to 0. There's no change, there's no difference, okay? And then we're gonna say the alternate is the mean for Bounty minus the mean for generic is greater than 0, where mu subscript B and mu subscript G, let's be specific. I know that we mean Bounty would be generic, but let's see what they talk about in there. I think it's like squares, something like that. Mean number of quarters a wet Bounty paper towel can hold. Okay, so mean number of quarters a Bounty paper towel can hold, and this would be the mean number of quarters a generic paper towel can hold. Okay? So that's a really good job with our hypothesis, okay? That's our state. Okay, we did our state and we did it very well. Clearly defined hypotheses, clearly labeled, okay? Plan. Let's name our procedure first. What are we doing? A 2-sample t-test for means. 2-sample t-test for means. That is our procedure. Okay? I guess I should probably say the difference of two. Let's do that. For the difference of two means. Or you could put mean of Bounty minus the mean of generic. So let's do our random, let's do our normal, let's do our independent. Random, it states random samples of paper towels. States the samples were collected randomly. Okay? Normal. N1 and N2 are both 30, which is greater than or equal to 30. Okay? Normal condition satisfied. And I'm going to say that 30 and 30 are less than or equal to 10% of Bounty and of generic paper towels. Okay? All right. All right, here we go. Let's do the do. Let's do the do. Okay, so if you need to pause that, pause it and get that down. This is really good job right there. We're doing a good job. We're doing a good job. Let's pat yourself in the back. Doing a good job. All right? Now we're going to do the do. Okay, the do. So we got to go back to the calculator, okay? Because we're going to find what our x bars are here, right? So to find our t-score, we need the mean of bounty minus, the mean of generic minus 0 over, okay, our, I guess, yeah, okay? And then we got to do what? The sample 1 squared divided by n1, and then the sample 2 squared divided by n2. No pooling. Pooling is only for z tests, okay? That's it. So this is what we got to do. We got to find what those means are. So we go back to the calculator, and we hit stats, and we hit calc. And I want 2 variable statistics, because I have 2 variables, L1 and L2, beautifully. So I got 117.6 and 6.64. So my mean for bounty is 117.6, and my standard deviation for bounty is 6.64. And then I got to do the generic. So all I have to do is scroll down, okay? Scroll down a bit. Wow, look at that, huh? Do we think there's a difference? Yeah, we do. Yeah, we do. The mean of generic is 88.13, and the standard deviation, for generic would be 6.30. Okay, get this out of the way. I need to go back here. Look at this one here. We did answer one of these questions in part A. Based on only the box plots, do we think the mean for bounty is significantly higher? Yeah. Box plots showed that, right? We're going to try to prove it with our test. Okay? So let's find our t-score. So this is going to be 117.6 minus 88.1 minus 0, right? Over 6.64 squared divided by n1, which is 30. And then that's going to be 6.30 squared divided by 30. We're going to get all this going here. So when I do that, I should get a test statistic of 17.64. Okay? Let's look at what our mean difference ended up being. Let's do that. 117 point, we might use that, okay? 117.6. 117.6 minus 88.1 minus 88.1, 29.5. That's what the mean difference we found was. Kind of big difference, right? We're testing to see it as it matches up to 0. So we expect a z-score really high. I never expect a z-score that high, okay? So my degrees of freedom would be 30 minus 1, so 29. So we do TCDF 17.642, 999, and then degrees of freedom 29. You could put a Z to the left, and you could put a Z to the right, and then you could put degrees of freedom. And that's going to be approximately 0. So when we go to our conclude, I'm going to probably have you write the conclude down rather than have listen and write it rather than me write it. So with a p-value this low, we reject the null hypothesis. And there is sufficient evidence to say that bounty paper towels are stronger than generic paper towels. Okay? That would be a good conclude. Part C, interpret the p-value. So, if the mean difference between the two paper towel strengths is really 0, okay, if the null hypothesis is true, we're assuming the null is true, assuming the difference between the strength of Bounty paper towels and generic paper towels is 0. The difference is 0. Okay, there's no difference. Assuming there's no difference between Bounty and generic paper towels, there is a probability of 0. Where is our probability? Probability of 0 of getting a mean difference as big as we found of 29.5. Okay? Purely by chance. There it is. A, B, C. All right? So I want you guys to go and do the CYU on page 644. So please do me a favor, pause that video, pause it, okay, and I'm going to have you guys do the CYU on page 644, and then I'll go over the answers. Okay, so I'm hoping that you pause the video. I'm hoping I can't be there over your shoulder all the time. Okay? All right. So in this one, here is the answer. I will go through the answer with you. We want to test. Oh, you know, I probably should have done. In our plan of this one, we probably should put significance level 0.05. I don't know that they take off for it, but I think it's a good thing to include, okay? And we didn't do that, so that's on me. I should have said that. So, for this new one, they say right away, we want to perform a test at the 0.05 significance level. The null hypothesis, mu1 minus mu2 equals 0, versus the alternate hypothesis, mu1 minus mu2 is greater than 0, where mu1 is the actual mean breaking strength at 2 weeks, and mu2 is the actual mean breaking strength at 16 weeks. Okay? The plan, 2-sample t-test. Okay, 2-sample t-test. Random. This was randomized, a randomized comparative experiment. N1 and N2 are both greater than or equal to 30. And, N1 and N2 are less than 30. But from the dot plots, there's no severe skew or outliers. You're gonna say, that's an outlier, that's an outlier. Well, not really, it's almost half your points. Knowing one piece of clot's breaking strength gives no information about independent. I would just say the samples are less than or equal to 10% of all breaking strengths. So, let's look at what they say here. Let's finish this up. So from the data, they got a t-score of 0.989 and a p-value of 0.1893. So, with a p-value this high, we fail to reject the null hypothesis. We don't have enough evidence to conclude there's a difference in the actual mean breaking strength of polyester fabric that's buried for 2 weeks, and that is buried for 16 weeks. Okay? There you go. Let's finish the game in 10-2. Finish the game. Here we go. Using the 2-sample T procedures, the normal condition. If your sample size is less than 15, use 2-sample T's if it's appear close to normal. If the data is clearly skewed or there are no outliers, don't use T. If the sample size is greater than or equal to 15, you can use it as long as there's no outliers or strong skewness. Large samples, N is greater than or equal to 30. All right, we kind of talked about that consistently all the way through. And that is the end of chapter 10. The end of chapter 10. Hope you enjoyed it.